Hello, my name is Kunal Jain, and today I will be presenting Team Assist Wheelchair Transfer Board device for DP3. Team Assist is currently working on a wheelchair transfer board device that fosters independence and safety within the wheelchair user community. Team Assist started by creating a mission statement that stayed mostly consistent throughout DP1, DP2, and even DP3, with one small inconsistency. Our mission statement started by stating that the product must be foldable and securely extend from a wheelchair. Having a product that securely extends from the wheelchair ensures that the user is independent, as they don't need a caretaker to bring the transfer board device to them. The one small inconsistency in our mission statement comes when we state that the wheelchair transfer board device must eliminate the use of body strength for the user. After further design, we found that this is not a viable option as it is very expensive to manufacture and very complex to design. Next, Team Assist created customer needs statements that highlighted the importance of safety for our design. As we're dealing with handicapped users, we need this design to be as safe as possible and as over-spec'd as possible. Our first statement was that customers don't feel safe with the current boards on the market. As they're not securely attached to the wheelchair, they have a tendency to slip or fall over. We also found that the boards should be able to fit any weight for any customer. Whether the user is 100 pounds, 200 pounds, or even 300 pounds, we want the transfer board device to be able to be used by a variety of customers. We also found that some people mentioned that the transfer boards on the market are currently too short. Having a board that is too short does not allow the users to transfer to surfaces that are far away from them. We want our board to be able to use for any transferring need, whether the desired surface is very far or very close to the user. Next, the team created a concept combination table that was used to narrow the focus for design. The concept combination table is comprised of subfunctions and solutions that range from very complex solutions to very simple solutions. As you can see, here are 3 out of the 6 routes designed by the teammates that were used for the next part of the gallery method, which is the sketches. Here are the 6 sketches of the 6 routes. On the left are my 2 sketches, in the middle are George's 2 sketches, and on the right are Tony's 2 sketches. These sketches were then used to create real NX CAD parts. On the left are the fold-out hinge design, in the middle is the puzzle design, and on the right is the roller design for the transfer board device. We were then able to go and select the fold-out hinge design for our final product. The fold-out hinge design was the safest, most reliable, most effective, and most aesthetically pleasing design. Here are some of the parts that went into creating the fold-out hinge design. Next, our group performed an FMEA, which pinpointed the hinge as the most likely to fail. Having a product that is for handicapped users, we need every single part to not fail. We want this to be as safe as possible. So performing the FMEA was critical. With the RPN of 320, we found that the hinge was most likely to fail. So later on in this presentation, I'll show you how we decided to go about fixing that. Next was the bill of materials and the CAD, which were created to help visualize the product that would go to market. Our bill of materials is comprised of in-house design parts by our team members, as well as 3 parts from McMaster-Carr. These 3 parts include the hinge, the C-clamp, and the assembly screws that were used to put the design together. The bill of materials came out to be $59.64. Here, as you can see, are the CAD, which helped us visualize what our product would actually look like on a wheelchair. We assembled our transfer board device onto a wheelchair, and this helped us with the size and seeing what it would actually look like in real life. Next was creating a final prototype that helped, again, visualize but actually feel what the team's design could look like. Our design is a scale, our prototype is a 1-to-1 scale of our final product. It includes birch veneered wood, which is the strongest type of plywood. Again, we use this to create the maximum safety for our product. Here is the copper piping that is used as the support system and what would eventually attach to the wheelchair. And as I talked about in the FMEA, the hinge system is the most likely point of failure, so we use gate hinges, which are the strongest types of hinges. Some product improvements that we found after testing our prototype was that we wanted to add some grippy texture to the bottom of our board. When placed onto a surface, we would not want our board to slip off. We need this board to be as secure as possible, so adding a grippy texture would help ensure that the board doesn't slip off. We also decided that maybe adding some cushion to the board would be beneficial, as it would be more comfortable for the wheelchair user. And lastly, this prototype was quite heavy, and we wanted to make it even lighter so that when the wheelchair user is trying to push their wheelchair on rough terrain or even up hills, they're able to do so without any struggle. Next, the team examined intellectual property and patents that are currently on the market as well as expired. This was cool because we were able to see some of the designs that were in our concept combination table, such as the rollers, that we did not decide to pursue, were pursued by another company. We were also able to take product ideas from expired patents and implement them into our design. One design implementation that we found was armrest that we thought would be a great addition to our design. Lastly, again, we were able to see how our product is aligned within the current market and how it aligns against the competition of the patents. We then performed a DFM and DFA, which helped put numerical values to our design. We were able to see that it would only take we could create 9.23 boards per hour, and that would be $59.64 to make each board. With a learning curve of 0.9 could be added to the laborers, as it does take some skill to create our product. And lastly, we found that it would only take 150 boards to break even. This means that any board after the 150th is pure profit. Overall, we found that our customer needs and mission statements translated into our final design, that extensive prototyping and CAD were able to create a product that we were proud of, and that the economic analysis performed on the board were able to ensure that our product is viable and competitive within the market. And lastly, that our team, Team 11, is ready to bring our product to the market. Thank you.